Okay, Chapter 3, Normal Probability Distribution. Chapter 6. In Chapter 5, we were talking about discrete and continuous variables and how to analyze discrete probability distributions. This is going to be about continuous random variables because they have an infinite number of possibilities. They're going to be seen on a number line. Okay. This is a continuous probability distribution. In Chapter 6, we'll study the most important continuous probability distribution, the normal distribution. There are infinitely many normal distributions, each with its own mean and standard deviation. So let's look at this little graph of a normal distribution. Notice that its axis is x, and its mu, or average of the population, this one's showing, is in the middle. And then one standard deviation as we create the distribution scale here. Okay, so we're adding one mean, the mean plus one standard deviations, two standard deviations, three standard deviations on the upside and the downside to get the whole spread of the data. Okay. So the properties of a theoretical normal distribution is the mean, median, and mode are equal because they're all going to stack up right here. So the median is here and the mode is here as well as the mean. It's a normal bell-shaped or unimodal or symmetric about the mean. Okay. So once someone says it's normally the data is normally distributed, you can assume these things. Okay. The curve is continuous. There's no gaps or holes. And for each x value, there's a corresponding y value. So as you go along the scale, these are all your x's here. All right, the normal curve approaches but never touches. It looks like it touches, but it never touches. Getting increasingly closer to the x-axis as it extends farther and farther away from the mean. The total area under the curve, the total area, the shaded area, okay, can be thought of as a probability. This here is the area, okay? It's also a probability, proportion, however you want to call it. The total area under the curve is 1 or 100%. The area between, here, let me clean this up a little bit. Between sorry, one standard deviation over apologize. Sorry. Let's see. The inflection points are where the one standard deviation over on each side meet the curve. The empirical rule says 68% of the data falls within here, and 95 falls within 2 standard deviations, and 99.7% of the data fall between here and here, 3 standard deviations. Okay, the majority of the data falls to the right of. When the majority of the data falls to the right of the mean, the distribution is said to be negatively or left skewed. To the left of the mean, it's positively or right skewed. Okay. Standard deviation along with the mean. Look at these pictures down here. If I have a mean of 3.5, that's where the peak is. Okay, at 3.5. One standard deviation over to each side gets you here, okay? Then second standard deviation, 2 standard deviations, and so forth. So this B over here has the same standard mean, but a different standard deviation. So it's smaller than this one, so it's less spread out, okay? Standard deviation describes the spread of the data. You can change the mean and keep the spread the same. It's just all going to be focused over a different point. Okay? So if you're looking at these, which curve has the greater mean? Well, right here is the mean of A, and right here is the mean of B, so A clearly has the greater mean. Okay, which curve has a greater standard deviation or a greater spread? Clearly B has a greater standard deviation. So here's an example. Scaled scores for New York State grade 8 mathematics test are normally distributed. The normal curve below represents this distribution. Identify 1, 2, and 3 standard deviations. So right here, it says it's normally distributed. Therefore, the mean falls right here. So this is the mean. All right, and as we identify different standard deviations as you go, right here is the first standard deviation. So this is 675 plus 35. So right here is 710. And notice that there is one, so this is 700, 710, 20, 30, 40, 50. So these are each 10 little markings on here. So when we have, sorry, let me write it up here. 7, that's one standard deviation, is at 710. 2 standard deviations come out to 745. So that's about here. And 3 standard deviations comes out to 780. So 50, 60, 70, 80 right here, 780. That's all on the upside. Now on the downside, you have 675 minus 1 standard deviation to get you the downside, 640. So that's right here, right, 640. 1 standard deviation on the low side, on the lower end, however you want to say it. Minus 2 times 35 gets you 605. So 605 is what, right about here. 3 standard deviations, 570, right there, 570. We have marked the 1, 2, and 3 standard deviations of this data set. Notice that we're using mu because we have, it doesn't say all, but it implies all. So we have all of these test scores for the 8th grade New York State math test. So that's the population mean, which is mu, and this is the population standard deviation, which is sigma. Okay?